Welcome to another video. We're going to continue on our course of looking at analyses that have brought in machine learning into their econometrics in a structured way. And today's video, we'll talk about something called the post-double selection lasso. And I'll show how this can be useful in estimating various applied regression problems. And we'll go through how it was applied to revise the results of a prior influential publication in the Quarterly Journal of Economics. This paper was published in the Review of Economic Studies in 2014, and the authors are Alexander Bologna, Viktor Chernozhukov, and Christian Hansen. And you're going to see some similar ideas as in the double debiased machine learning video that precedes this one. And in particular, we're going to think about something called post-double selection, which is going to be a useful way to estimate treatment effects in linear models. We have a very similar setup as in the double debiased machine learning, except our functions, our semi-parametric functions, are actually going to be approximated by a linear n parameters specification. So the notation in this paper in the restud is different than the notation that I have on this slide. I'm making it consistent with the double debiased machine learning video that precedes this one. So the steps that we follow are going to be fairly similar to the double debiased machine learning. We're going to use lasso to select the x's. And we're going to do it in two phases. So first, we're going to select the x's that matter for our outcome in the outcome equation. Then we're going to select the x's that matter for treatment in our selection equation. And then we're going to take the union of the x's that were selected in each of those equations and put those on the right-hand side along with D, and then just run a regular regression of y on D and those selected x's. This is called post-double selection because our final regression has x's that were doubly selected in both the outcome and the selection equations. And the key idea is that we're avoiding this regularization bias from the shrinkage part of lasso by only looking at the selection part of the lasso. So basically, if we go back, we only want to look at which variables have a non-zero coefficient in these two equations. We don't care about the coefficient value. That's not going into our econometric analysis at all. So then the authors revisit a very influential paper by Donohue and Levitt in 2001 in the QJE, and also was discussed in the book Freakonomics in the mid-2000s. And the question was whether the Supreme Court's Roe versus Wade ruling ended up reducing crime. So the intuition is that unwanted children are the ones who are going to likely become criminals. And so if we legalize abortion, then we'll reduce the number of criminals 15 to 30 years later. So the original paper did a two-way fixed effects model with year and state fixed effects. And the data was at the state level, and it looked at different crimes and different abortion legalization policies and so forth. So they're looking at the abortion rate in the state as the treatment variable, and then they have state and time fixed effects, and then some covariates here. And the outcomes are different measures of crime. And then the W's are going to be different state level covariates. And one potential issue with this type of analysis is that the specification of W could be really important. And in particular, we might want to have really flexible forms of W. And then if you read this paper by Belloni and Chernozhukov and Hansen, they're going to show that indeed the point estimates get closer to 0 in magnitude and the standard errors get larger. And basically, a lot of the results get overturned. So if you want to implement this approach, this works just as well in like a difference in differences model with two-way fixed effects. I've done that in one of my publications several years ago. And basically, you can use this same Stata module that has both the double debiased machine learning functionality, and it also has the PDS Lasso functionality and some other Lasso functionality with instrumental variables. And so this is a very versatile method that I think nobody has a reason to not implement in their diff and diff or instrumental variables type of analysis. So I highly encourage you to look into this and see if you can add some more credibility to your analysis. And as I said, I think this is a method that everyone should be using whenever it's applicable to them. So I hope that you've found this video informative and helpful. And in the next video, this will conclude this mini-series on machine learning methods in econometrics. We're going to talk about a couple of different methods for detecting heterogeneous treatment effects and estimating the average treatment on the treated. So I hope you'll join me for that video as well, and thanks for watching this one.